Hey there, Mr. Wilford here. I just wanted to go through and talk a little bit about what we're going to do in week 2. We are going to continue with our chapter 10, all about the conic sections that we started talking about last week. We're going to continue with the next 3 sections, sections 4, 5, and 6. I just want to go through and talk a little bit about each of these again. Just a reminder again that on the right hand side of your online textbook there's all sorts of good examples, video examples, and an interactive practice quiz for each section as well. So make sure you utilize that information there. Let's go over and talk a little bit here about section 4, hyperbolas. And a hyperbola is very similar in some ways of an ellipse. And if you can imagine an ellipse, cutting the ellipse in half and then breaking that apart, then you would end up with what we call a hyperbola. Now, a hyperbola will also have focal points or foci, and we'll see what the graph looks like in just a second. But one of the things that is very similar is this thing called constant difference of a hyperbola. And there's a formula again that we're going to be using here. It has to do with the distance formula. If you remember, in an ellipse we added these two things together. In a hyperbola we're going to subtract them. So again, you have to know how to use the distance formula. A point on the hyperbola and the focal point minus a point on the hyperbola and the other focal point. And we're using the distance formula twice, and then we subtract these. Again, a calculator is very helpful to do some of this stuff, and we can get a constant difference of 8 here. Now, once we really look at the graph of a hyperbola, you'll see what this is. When we break these things apart, we call them branches. There are 2 branches of a hyperbola. A couple of other terms here: transverse axis, vertices of a hyperbola, conjugate axis, covertices of a hyperbola. We'll talk about what those are in some examples here that we look at. Now again, this can be a little bit overwhelming and maybe a little bit confusing, so try to really just take a look at this stuff and then look at some of the examples, and I'll try to give you a few hints as we go. So we have a hyperbola, and the hyperbola graph is actually in red here, and we can have a horizontal hyperbola or we can have a vertical hyperbola. Again, we have our vertex points here. This time our focal points, our focus points, will be outside of the 2 branches. We have our equations here, and again, for horizontal it's one form, for vertical it's another form. If you remember, in an ellipse I mentioned that your a squared was the larger of the 2 denominators. In a hyperbola, the first denominator will always be your a squared. So you don't really care about which one is bigger or smaller. You want to look at the first denominator, and that's going to tell you your a squared. Now the reason a squared, or a, is so important is because that tells you the distance from the center out to the vertex points. Also, if you look above that, that's going to tell you if it's horizontal or vertical. So a squared is here. If I look above that, I have the x-axis. That would be horizontal along the x-axis. If you look at this second one, a squared is with the y. That would be vertical along the y-axis. We have a number of other things here, but everything is pretty much with the distance from the center to the vertex, the focus, and then your b tells us the covertex points. So again, we're going to kind of go back and forth, and they're going to give us information about the graph, and we have to come up with the equation, or the other way around. They're going to give us the equation and we need to come up with the graph. So in this example here, they're giving us this graph, and so we can see a bunch of different things going on here. The distance from the center out here is 5, and so that's going to be my a. The distance from the center out here is going to be 3, and so that's going to be my b. So basically, if you kind of jump from the graph to the equation, I know that it's going horizontally, I know that a is 5. 5 squared is 25. And it's going to go with the x variable. Minus, hyperbolas always have minus negative signs here. And then this distance from the center out here is 3. 3 squared is 9. So this is my equation of that hyperbola. Again, just make sure you look through the examples here and try to follow along with the steps that they have as well. Again, here they're not giving us the graph, but they're giving us information about the graph. I would certainly sketch this graph out, plot some of these points so you get a picture of what the graph looks like, and then again you can plug the A and the B in here. Once again, you can shift the hyperbola around so that the center changes, and that's really what this is talking about. The H and the K will tell you the center, so it's not always going to be, the hyperbola is not always going to be centered at 0, 0, the origin. Sometimes it's going to be shifted around a little bit. As this example here shows, if we go from the equation to the graph again, first thing I notice is that the center would be at the opposite of this is 2, and the opposite of this is negative 3. So over 2, down 3 is the center. That's where you want to start. I look at the first denominator, it's 16. That's going to be my a squared. I look above that, that's the x variable. So I know the square root of 16 is 4. From my center point, I'm going to go to the right 4 and to the left 4. Those will be the vertex points. Then the covertex comes from the other denominator, the second denominator. Square root of 49 is 7. So I'm going to go 7 up and 7 down. Okay. They give us some other things here. You can kind of look at that. But basically that's it. And again, if you have a graphing calculator, sometimes that helps just to kind of get a better picture of what's going on. Once again, take a look and at the problems that you need to do for section 4 for your book assignment. And then on to section 5. Now section 5, parabolas, is something we've actually talked about before. You should have done parabolas earlier. And so parabolas, really it's nothing new. There are a few extra points that they throw in here, however, when you're talking about it with conic sections. The focus point is something new. That's always going to be inside the parabola, right here. And the directrix. The directrix is a line that's opposite the focus. It's always outside the parabola. Now, normally we talk about parabolas being going up or down. In this section, we're also going to talk about parabolas opening to the right and opening to the left. We have our distance formula again that we use, and we can use that to kind of help us find the equation. There are a lot of steps here, so you want to make sure you take your time and look at each step and the reasons for those. But basically, again, it's taking a point to the focus and a point to the directrix, and really just plugging in these numbers and then simplifying it until we get our equation of a parabola. Again, they give us a nice little chart here to kind of determine what we're talking about horizontally and vertically. Your parabola can go, and this is the axis of symmetry. This is the axis of symmetry cuts the parabola in half. We can have horizontal, which would mean that it's going to open to the right or to the left. And we can have a vertical axis of symmetry, which means the parabola is going to open up or down. And then these are the equations that go along with those. And they give you some hints here as far as what P is. If this fraction here is positive, it's going to open up. If it's negative, it's going to open down. Again, this is one of those things where you can kind of take a look at a graphing calculator, use a graphing calculator and plug these things in. That can kind of help you that way as well. Here we have equation of a parabola. We want to find the equation, and they give us this information. The vertex is at 0, 0, the origin. This distance is 6, that distance is 6, And so basically P is 6, and we can kind of plug that in and then use that to find our equation following the chart up here. Okay, here's another one. Same kind of thing, and they give us some information about the graph, and we want to come up with the equation. Same thing, we can take a look at the distance to find P, and then plug that into the formula to find our equation. Now once again, just like all our other conic sections, we can talk about moving that center point. In this case, we're going to move the vertex point. So by adding or subtracting something to x and to y is going to change our vertex point. And the hint here again is to take the opposite of each of these. So the opposite of what you're adding or subtracting to x, the opposite of what you're adding or subtracting to y will change that vertex point. So again, make sure that you look over the examples and kind of try to follow along with those examples. If you have questions, let me know. And again, here are some of the problems that you're going to be working on for this section. Again, this can be a little bit confusing, so make sure that you ask questions if you have them, and I can certainly try to go through some different examples and problems as we go through this. Also, in section 6, we're going to be identifying conic sections, so this is kind of putting everything together. And we have our standard form for each of these. So we have our circle, and then we have ellipse, hyperbola, and parabola, depending upon if it's horizontal or vertical. And they're going to give you different types of equations, and you have to be able to identify them. A helpful hint here real quick is a lot of times if you are adding the x squared and the y squared, if you're adding it, it's either going to be a circle or an ellipse. If you're subtracting, then it's going to be a hyperbola. And then if only one of the variables, either x is squared or y is squared, then you're looking at a parabola. So that's kind of another hint for you to watch for. So like example B here, I see that x is squared and y is not, so I know it's going to be a parabola. Here I'm subtracting, so I know it's going to be a hyperbola. Okay, the thing you have to be careful of is whether it's a circle or an ellipse. Sometimes they try to trick you a little bit with that. Here's some student to student, some helpful hints here. You can read over those. And then they also give you an equation in this form here. This is kind of a different form where everything is written out in terms and it's set equal to 0. The thing here is to write it in order, in this order, so your x squared is first, then your xy, then your y squared, and so on. And then you can grab the coefficients, the a, b, and c, and plug it into this formula. And depending upon if it's less than 0, greater than 0, or equal to 0, that will also help you determine which of these conic sections it is. And you can read through some of these examples here and see what's going on with that. And then finally what they do is a couple of examples here trying to take a standard form of equation of the conic section, and this involves completing the square. So hopefully you remember a little bit about completing the square. This can be a little bit tricky too. There's a little bit of work going on here, so make sure you see where these numbers come from. And what they do is they transform this equation into this, and then they can say, well, this is a parabola. Same thing here. They do the completing the square actually twice, and then they can rewrite this equation so that it looks more like an ellipse. With these sections here, I would for sure take the time and go through some of these interactivities, these links here, and try the practice quiz just to make sure that you have some of this stuff down. And then there's a real-world application problem here, and then some of the problems that we're doing. So take your time with this section. With actually all of these sections, they're a little bit challenging, but hang in there. And if you have questions, please let me know. And otherwise, have a great week. Thanks.